Hello everyone, this is Debabrata once again, and today I'll be taking a session on the matrix. So my classes will be intended for those students who are suffering a lot in their C language journey, because when I have done this C language, I really didn't write what I can remember. I didn't write any single program even because I couldn't understand what was the purpose of C is serving and why should I learn C. I didn't have any single idea. It was on second semesters, I guess, but I couldn't understand a single thing. And if you ask me about the matrix scared me a lot. Believe me, all those things I couldn't understand why I need to rotate a matrix, why I need to print it in a spiral way. So I really didn't get anything in the matrix. So it was really scary at that time. So I will try to make all those things means understandable to you in some simple way. I will write down all the programs, just go through that, try to understand what I'm trying to mean. If you are not able to understand anything, I'll be just pinging me in the comment section with the codes. If anything is not running, I'll be trying to help you over there. So as a prerequisite, I can say, like, we have already done one basic class of matrix. We have done already one class on matrix. Just go through that. You will be able to experience, like, there are few things that will make matrix easier. Yes, you have heard it correctly. The thing is, matrix is easier than array because in matrix, the loop part is quite common. Last day means in the last class, last matrix class, we have just written only one for loop, and that for loop was applicable to all the programs. We do not need to think over the for loop. So for loop was common, and that loop is basically used in 90% cases I have seen. 90% programs, 90% programs I have seen that can be solved with that loop, and that was very effective loop. So today also I'm gonna use that loop in our programs, but that makes matrix program easier. Only you need to think on those 10% programs. And apart from that as well, matrix programs has some finite set of questions. It is not like array. Array can be applied means for stack, for queue, for circular queue. You can go to any of the programs. There are variety of programs you can write with array. So, but in matrix, if you simply check in Google, if you go to different sites, different portals, you can see the programs are quite common. They are rotating the matrix, they are shifting it up, they are printing it reversely. So the programs are quite common. So that's why I am telling matrix will be easier for you than array. So today I'll be showing you a few of the programs. So my request is if you are following my playlist, then it is okay. If you are not, if it is your first class, my request will be just go through the previous class where I have already shown some basic activities of the matrix. And obviously you have to practice them all. So practice is the main keyword here. So if you practice, everything is achievable. So today we will going to have only two topics, nothing major. So first topic I want to mention, like, enter a matrix and check if it is an identity matrix or not. So example of identity matrix, something like this, where all the diagonals will be filled up by 1 and the elements which is not in diagonal will be filled up by 0. So again, it probably you will be more confident in mathematics because I have done mathematics a decade ago when I was in a college. For the last time I have done matrix related means mathematics at that time. So I forget what is identity. So identity means what I can see. The diagonal element should be 1. Non-diagonal elements, anything which is not in diagonal, will be considered as 0. Okay, left diagonal. Diagonal means I'm meaning left diagonal. So I have a basic program written here, how to take input without wasting time. I have already written that. And this is quite common program, and that will be used in all of our exercise today I will do. Because it is a program where I am taking the size of the matrix because it has to be a square matrix. We do not have anything like row and column. And I'm just entering the elements. That's all it is written. So now, and this is the loop I am talking about. And I'm going to use this loop today again. So, so what I will do first, I will put up something like f equals to 1. F equals to 1 means, yes, it is identity matrix. I'll be saying. That means at the end of the loop, I'll be saying at the end of the loop, I'll be saying if f equals to 1, I'll be saying yes, it is identity matrix. It is an identity matrix. And if it becomes 0 or the value changes somehow inside the loop, so I will be saying no, it is not an identity matrix. So it is like our society. Suppose if you say someone like he is good or she is good, everyone in our society or in a social media, everyone will start to criticize him or her. Like, look, he or she has a problem like this. So he or she is not a good person. So look, it is an example, he is not good. Look, she have done this. So that means she is not a good lady. So this kind of conversation I have seen a lot in social media. So I will apply that thing in our questions as well to solve our exercise as well. So first I will tell like, okay, he is a good guy. Int f equals to 1. Now, if anything happens, I will say, look, he is not that good. He is pretending to be a good person, but in actual, he is not a good person. So I'll be trying to check his fault. So his fault will be when it is a diagonal element, means I equals to j, and somehow the matrix is holding some value which is not equals to 1. Then I will say, look, I got a fault and he is not a good person. So at that time, I will mark it as f equals to 0. So if everything goes fine, then f will remain 1 and I will print it is an identity matrix. But if anything goes wrong, any single point, if I can catch, like, okay, this is the problem where suppose only single value, I will mark them as f equals to 0. I will quickly say like, okay, he is not that good. I found a fault. So it is something like that. If the element is diagonal and if it is not 1, then it is a fault. Otherwise, it might also happen I not equals to j, means it is not a diagonal element, but aij is not 0 as well. Aij should be 0, but aij not equals to 0. So non-diagonal elements should be 0, but somehow it is not. Here, diagonal elements should be 1, but somehow it is not in this case. If it happens for one element only, then also I will mark it as a 0. So till the end, if f can remain its dignity, then I can say, yes, it is identity matrix. If somehow the value of f changes, I will say it is not an identity matrix. So very pretty much simple. And if you check the loops are common. I am visiting all the places and checking element from all the places. So these loops will be fixed. We have used that loop in the previous class as well. These loops are fixed and will be used to visit all the positions one by one. So now enter the size of the matrix. Suppose let me deal with 3 and let me insert the values, something like this. And it is saying, yes, it is an identity matrix. So now if I want to run with some wrong value here, suppose let me run with 1 0 0 0 0 0 1, and here I will put a 2. That should not be there. But if the program finds any mistake, it will say like, no, it is not an identity matrix. So it is pretty much simple, but again, the concentration on this loop is being used. I am telling this again and again and again because your concentration should go into that part. Like, this loop will be used to get all the elements one by one. So that's the thing. If I proceed and suppose if it is asking for shifting up means suppose we have some value like 10, 20, 30 like this, 40, 50, 60, something like that, and I want to shift it up, means to the upwards. So you can see 40, 50, 60, previously it was the second row and now it became the first row. Same 70, 80, 90 also shifted up here, and previously it was on the last row, but now it became the second row. And the first row moved into the last position. So if we want to do the same thing, first I need to take a backup of the first row. What I need to do? I need to take a backup of the first row, all the elements of the first row. After that, I will shift all the rows one level up, and last step will be to print the first row into the last position, for which I have taken the backup. So only 3 steps. So let me do that. First, let me take the backup of the first row. So let me delete all these things. Let me delete all these things, and I'll be trying to show you how I can show you, I will try to show you some programs where we will not using this conventional for loop. I mean this for loop. I will try to create some situations where we need to write some different kind of for loops. Okay, because last class it was not almost all the programs, I will say all of them were solved using these two loops. But today I will try to move away from that part, and I will select few programs where we have to make some nominal changes. So first, let me take a backup. So first step 1 is taking backup of first row. So how to take a backup? First, I will take a array int arr, and int arr something called 50. I guess that will be enough, and something called int pause equals to 0. Or pause is not needed, I guess. Let me check. If needed, I will take it quickly. So I equals to 0 to I less than n. Okay, here I can do one thing. I can play with different number of row and columns. So let me take different number of row and columns. It can be different. It can be different row and column numbers. Let me play with that. RNC. Let me take RNC. Obviously, at the time of input, instead of n, I can put it here as R, and here I can put as C. So again, rest of the things are same. So until the column number, I can take all the columns of the first row, I will take a backup. What I will do, I will simply write arr I will be like, I will be taking it from the first row itself, and the columns numbers will be changed. So the first, when I equals to 0, means the first column of the first row will be placed in the first position of the array. 0 is fixed, means all the elements will be fetched up from the first row. Now the second value, means from the second column, will be stored into the second position of the array, that is position 1. So again, go like that. All the elements from the columns will be stored into the single dimension array. So by which I can take a backup. After that, step 2, shifting, rest of the rows one position up, rest of the rows to one position up. So if I want to do that, I have to take that common for loop. But here, I'm not going to start from the 0 row. I'm going to start from the second row, that is I equals to 1, row number 1. Okay, not I will start from row number 0, because first row I have taken the backup already. So what I will do, it will be copied into the previous row. All Aij will be copied into the previous position. So here you can see I have written ai minus 1j will be holding the value of aij. Means all the values will be copied to the previous row, ai minus 1. So let me write the last step where I will put the backup row into the last position. You can see here as well, 10, 20, 30. Now it is in the last position, if you can see my cursor. So everything has been shifted up. Now I have to copy from backup to the last row. What I will do, I will do the reverse of this thing. So I will take one by one, I will take all the values, but arri, now it will be copied to a r minus 1, that is going to the last row, and I. So equals to arri. First time I took the backup, I took the backup from the first row, as 0 is indicating the first row. Now I will do the reverse, the vice versa. I will copy the elements from single dimension array and put it into a r minus 1 row. So the last row will be called as a r minus 1. So that's the thing. So if I run, I think everything I have written correctly. So let me check first if it is working or not. So 3 rows and 4 columns. Let me put the elements 10, 20, 30, 35, suppose 40, 50, 60, 65. You can play with any number of values, any values doesn't matter. Okay, sorry, I forget to print it back. So let me print the array, print the matrix now. So everything has been done, but I forget to print. So I can write something after shifting the elements are. I write that. Let me simply write printf statement here. And let me put a space after each values, and I will put an enter here. I guess that is good. Now if I run again, 3 rows and 4 columns, let me give some quick values without thinking a lot. You can put any values, 900, 1000, anything you can give. Okay, I'm doing something wrong probably. Okay, again, I'm wasting time. Yeah, it is not an at the rate. I will just simply print the values here. Okay, so let me run it once again. Let me close it. Let me run it once again. Where is the compiler? Yeah. So again, quick inputs. Probably this time it should run. Yep. So it is something like this. You can see 10, 20, 30, 35 come to the last position. 40, 50, 60, 65 goes into the top. 70, 80, 90, 95, which was the row number 2 or the third row or row number 2. That becomes the middlemost row currently. So it has been shifted one place up. So that is the thing. I will request you to hold my screen, just put my screen on hold and just try to type all the programs by yourself. Until here, I have taken the input. After that, what I have done, I took the backup here. After that, I shifted it up one place. And after that, I copied the backup thing again into the last row. R minus 1 denotes the last row. Here it is. Okay, and after that, I have just printed them back. That's what I have done. So if I proceed now, like right lower half, what does that mean? Suppose anyone has given something like 10, 20, 30, 40, 50, 60, 70, 80, 90, and you just need to print, okay, I think that is wrongly written. So it has to be something like this. The example is wrong. So it has to be something like, okay, let me correct it out. Yeah, so I have changed the value. So it looked like something like this. 10, 40, 50, 70, 80, 90. So the lower left half. Okay, sorry, again, one mistake. It is not the right lower half. It has to be the left lower half. Okay, so I have to make the changes once again. Just give me 1 minute once again. So now I think the words are correct. It is left lower half. Okay, so if I want to fetch this out, what will be the condition? Again, this has to be the square matrix. So I will just remove R and C. It has to be N. And I will say like enter the size of the matrix and it has to be N. I do not need R and C to be taken separately and everything in the for loop will convert it to N. So now I do not need these steps as well. Let me delete all these things. And here I can say like the desired elements are, means I'm looking for lower left element. So first let me find out what are the positions I'm looking for. So the general positions are 0, 1, 0, 1, 0, 0, 0, 1, 0, 2, 1, 0. These are the positions I'm writing. It is not the value. Value can be anything. Value can be 50, 500, 5000, anything the value can be. But I'm talking about the position. So here I need to print the positions like this. So here I can see a common phenomenon like the value of I should be greater than equals to j. You can see here I is equals to j, but here I is greater than j, and here I is greater than I is equals to j. But here in this position, I is lesser than j. So whenever I is greater than j, I will try to print that. If it is not, I will not going to print. That is my criteria. So let me write that and let me check if it is working or not. So here, simply I will put some condition like if I is less than equals to j, then only I'm going to print the value. Let's see. Oh no, sorry, I is what I have seen greater than equals to j, not less than. Let me check once again. Yeah, it is should be greater than. So here you can see 1 is greater than equals to 0. And here 1 is equals to 1. But here 1 is less than j, so I'm not going to print that. So I will print until I is greater than equals to j. You can see in all the examples, I is either greater than or equals to j. So if I print this out, okay, something goes wrong. Okay, it is not R anymore, it is N, because I am working with a square matrix. Now if I run, okay, actually I'm writing simultaneously in this class. It is not like the programs are already written, so it is quite normal that I'm making the mistake. And even I'm not someone belongs to like Superman community, so I make mistakes. Even I suffered a lot when I was a student, so you can also do the same. You can make many more mistakes, but never quit. Never quit. Okay, if you are facing any problem, even non-technical as well, just let me know. So if I enter that, you can see, yeah, lower left half is being printed. Okay, so lower left half is being printed here. So they can ask for some upper right half. They can print like lower right. They might be looking for upper left part. So they can be anything. You can find everything in the exercise as well. I have created one exercise. You can go through that as well. But again, it was a simple one, and I have used that common loop. So now, if anyone asking for the mirror image means, suppose if you have something like 10, 20, 30, and now if you put a mirror in between, here you can see the reverse thing. So here it is 10, 20, 30, and in the mirror you can see the reverse, 10, 20, 30 in the opposite way. So how can you print it out, or how can you solve this solution? Obviously the columns I need to print in a reverse way. Let me show you how I'm thinking the solution. So here it is. I will take the input, and here you can see R and C, whatever you can want, you can write. But I will be writing this program with the square matrix itself, because I do not prefer to change it again and again. So square matrix is enough. So what I will do, I can write the mirror image is, I will be going normally. The rows will be going normal, but the columns will be started from n-1, and it will be ending at 0, and every time it will be j equals to j-1. I do not need any condition to be written here, and I guess it is done. Simply from instead of 0 to n-1, I'm running it from n-1 to 0, just the reverse one. I'm printing the columns in a reverse way. Let me show you how I'm thinking. So let me play with the 4 size matrix now. 10, 20, 30, 35, suppose 40, 50. You can put any value though, but I'm putting something which shouldn't create any pressure in your mind. So the normal thing, suppose 11, 22, 30. If I write that, you can see the columns are being printed in reverse way. 10, 20, 30, 35 has been printed in a reverse way, like 35, 30, 20, 10. So a nominal change I have done in the loop. I have just printed the columns in a reverse way, from the maximum value to the lower position. Maximum position to the lower position, from n-1 to 0. And it will satisfy our purpose. So I think you got the idea. If not, just let me know in the comment section, or just let me know in the class as well, if we are doing the offline classes. So here it is saying transposing the matrix. Transposing matrix is a mathematical word again, and I have done mathematics probably a decade ago. So transposing matrix means you can see all the elements change their place. With respect to diagonal, you can see 30 was previously at the top right corner. Now it changed the place and it is now in the left bottom corner. You can see it changed the place. So if I put a line through the diagonals, you can see everything got reversed. If you can check the position of 20 and 40, everywhere it has been changed. If you can change the position of 20 and 40, these are changed. If you check the position of 80 and 60, those are changed. So everything has changed. So I will try to track the changes. I will try to track the changes. So if I write those things in the notepad, you can see previously 30 was the element like A20, no, A02, row number 0, column number 2. But now it becomes, suppose let me take it as B. In B, the position of 30 is currently 20. You can see. Same if I take any other elements like 40. So 40 was previously at, in A, it was previously like A10, but now in B, it is modified to 01. So I can see the changes are reversed. I is becoming J and J is becoming I. Means row is becoming column, column is becoming row. A very simple one. So what I will do here, I will quickly, instead of AIJ, I will print AJI. Everything else will be same, but I'll be changing the positions of row and column. And I guess it will print the transpose matrix. So I can write the transposed matrix is something like this. Let me run. Let me play with a 3 size matrix and 10, 20, 30, 40, 50, 60. And it is pretty normal one, pretty simple. But believe me, okay, no, something I have done wrong. Something I have done wrong. Okay, sorry, something I have done wrong because the loop is already reversed. This loop, at least it should be in a normal way. I equals to 0. I have done that on the top of the last program. That's why it created the confusion. So yeah, that should be the normal one. J should be the normal. And I will just, it will be a simple loop. I will just going to print AJI. I think the idea is clear. I'm not going to do anything tough. The loop, I have to use the common one. But yeah, due to the last program, it was changed. I forgot to change that loop. But here you can see the loops are normal. I just need to print AJI instead of AIJ. I have to print AJI. Let me try once again because it is very simple program. 10, 20, 30, 40, 50, 60, and 70, 80, 90. If I do that, you can see everything has been transposed. Okay, everything has been transposed. You can check the position of the 30. Previously, it was here. Now it has been changed to here. So everything has been transposed as per the mathematical term. I do not know mathematics much, but still, it is it was the easiest, I guess, example. So, yep, if I proceed now, probably we are done with the topic 1. So if I proceed to topic 2 now, where we can see some complicated programs, I guess. So topic 2, yes, complex programs. So first thing is matrix multiplication. It is something really very hard. And every time I copied this program, it is pretty much important. It came in my semester exam. It came in the lab exam. So every time what I have done, I have written it, means I copied the program in a piece of paper, and I just, in the exam hall, I just copied it down. That's all. That's all what I have done, because there is no chance that I can understand these things well. I really didn't know even how to multiply two matrix in mathematics. But yeah, if I check now I know what needs to be done. So suppose first you need to know the mathematics. I will not going to concentrate much on the mathematics side. So Let me take few variables here. So first of all, the first matrix is 2 into 2. Suppose it is the R1 and it is the C1, the row and column of the first matrix, and it is the row 2 into column 2. Suppose I'm explaining mathematics first. If you do not know mathematics, just skip this program. Otherwise, it is going to be very tough for you. So second matrix is having 2 row and 3 columns. So what actually happens in mathematics is we compare these two things. Means we compare column 1 with R2, the row 2. If they match, then we can do the mathematics. We can do the multiplication. If they do not match, we can say like, yeah, it is not feasible. We cannot multiply them. And as a result, what we get the row 1 and column 2. The result becomes like a 2 by 3 matrix. A 2 by 3 matrix. Okay. C1 and R2 is being compared if they are same or not. If they are same, the final array or the final matrix looks like 2 into 3. Means it looks like R1 and C2. So let me write until what we have explored. Let me write that in the program. So it is going to be something tough. I'm saying that from the starting. So enter the row size, enter the number of row of matrix 1. And I never did this program in my college days. Really, I am still scared. I am still imagining those days where I couldn't understand anything, but I appeared for the Viva. And it is a common situation for most of us, actually. So matrix 2, and I can write something called R1 and C1. It was the row and column of the first matrix. Let me write all of them, R1, C1, and R2 and C2 for the row and column for the next matrix, the second one. So if I copy, okay, here I have to write matrix 1. Both the inputs are for matrix 1. Now I will take both the inputs for matrix 2, and it will be R2 and C2. So first of all, first of all, let me take the inputs, enter the elements. Okay, no, first of all, I will do something like if what I have explored here, C1 has to be, C1 equals to R2 has to be. So if C1 not equals to R2, I will quickly say printf cannot multiply. Multiplication not possible. I can write something like this. If C1 is not equals to R2, the column of the first matrix is not matching with the row of the second matrix. But if it is same, then I'll go forward and I will try to take the input of matrix 1. Let me do the first simple things. So obviously here, I'll be taking input of the matrix A, suppose. And here I have to use R1 and C1. And let me take three matrices generally, A, B, and C. Two matrices A and B first, and to hold the result, I will just introduce another matrix called C. Yep, I guess. So that's all. So let me take an input of second matrix as well. So I can enter the elements of matrix 2, and it will be till R2 and C2. And it will be something Bij I have to write. I think that's all on the input part. Now what I need to do, I need to calculate. So transport matrix, those things are not needed for the time being. So what I will do, now let me show you the examples, means of the mathematics. So what I need to do, suppose, obviously we have 2 rows and 3 columns as R1 and C2 is suggesting. So now what I will do something like for, I will, our matrix will look like something like this. We are going to have 2 rows and 3 columns, you can see. So let me put some spaces because I will write many things here. So let me iterate through this. I equals to 0, I will be less than R2 minus 1. So let me write that. So I will check, I will visit I0 to R minus less than R1 plus plus I equals to I plus 1. And here I will iterate from j equals to 0, j less than C2, because the final array, here what I'm going to do, I'm going to store it into the C array. And it is the specification of the C array, because C array, as per the mathematics, it has to be, the dimension of C array will be R1 and C2, as I have explained here. It will be R1 means 2 by 3. So the final array will be 2 by 3. The final array will look like something like this. Okay. So something J0, J less than C2 and J equals to J plus 1, something like that. And here somehow I'm looking for, I'm just looking for something like this. Cij, it will be something. So let me check what will be the mathematics of Cij. So if I choose any position, so let me choose this position, that is 0, 0. So if I choose 0, 0, means I equals to 0 and j equals to 0, suppose. Then all the elements of 0 row of the first array will be selected, and all the elements of the B matrix with j equals to 0, means column equals to 0, will be selected together. That means 0th row of the first array, that means these 2 elements, and 0th column of the second matrix, that is this one. So I have to choose them out. So what will be the solution then? What will be the value? 1 into 5 plus 2 into 8. That value is going to sit here. 1 into 5 plus 2 into 8. That means what I'm doing, that means I'm trying to do A00 into B00. You can see, you have to be very cool and calm. And we are doing A01 into B. This term will be going to called as a B10. I'm doing it very slowly. So you can see all the elements of 0th row of first matrix, you can see everywhere it is 0 with A. The following part is changing, but these 2 parts with always the row of A is always 0 and the column of B is always 0, because we are dealing with 0, 0 element. Okay, so if I proceed further, the second element, it means I equals to 0 and j equals to 1. I'm talking about this. So that means the 0th row of the first matrix and column number 1 of the second matrix, something like this. So the answer will be like 1 into 6 plus 2 into 9, something like this. Okay, 1 into 6 into 2 into 9. So if I write, okay, it was the situation of I0, J0. So now I will be writing some situation for I equals to 0 and j equals to 1. So here what I'm doing, A00 is being multiplied with, okay, let me make it large. So what I'm doing now, So what I'm doing now, 1 is A00 and 6 means B01. Let me do it very calm way. If you are not familiar with the positions of the matrix, I will say like, think in a cool way. So it is 00, it is 01, it is 02, something like that. So I am also taking time to think it. So 1 into 6 means 1 into 6 means 1 into 6 means A00 into B01. Now 2 into 9 means A01 into B. What will be the place? B11. So again, you can see the row part of A matrix is fixed always. It is similar to I. And the B part, the column is fixed. It is always 1 because J is 1. So we have to make them fix. So that means if I write it here, it will be, but the thing is, the other part is changing. This part is changing. This part is becoming 0. After that, this part is becoming 1. Similarly, this part as well. This part is becoming 0. After that, this part is becoming 1. So we have to iterate. We have to put everything on hold here. So when I am coming to I and J, I will put everything on hold, because for this position, I have to go through another loop that will calculate this complicated equation and derive some answer like 1 into 5 plus 2 into 8. What is the answer? 5 plus 16. So it will derive to 21. So I have to hold at this position. At this position, I have to hold. I have to put something like int sum equals to 0. And I have to calculate now. So for that, I will introduce another variable called k. And k will be starting from 0. And k will be iterating till, let me think, iterating till, so it will be iterating till 0. And after that, it will be 1. So iterating till less than 2. So that means it will be something less than, I can write C1. Okay. And I can write k equals to k plus 1. It is purely mathematical. So what I will do now, I will simply write, first I will calculate the sum. Sum equals to sum plus A, I part will be fixed and the k part will be changing. Same for B, the first part will be changing, but the j part will be same. So I will keep gathering all the sum, and when the sums are collected, I will put that into Cij. So here I have to give a pause. I cannot quickly write the result into Cij. So you can see this, the pattern, the I is fixed for A, but K is changing. Same for B, K is changing, but the J part is fixed. J will be similar to the position. And at the end, on that IJ position, I will put the sum. So it is purely as per the mathematics. Here as well, you can see, if I find the similarity, I part is same for these two positions of I, and J part is fixed for these two positions of B. The columns are fixed so that I'm able to find the value of I, J position. And this middle part is basically K. K is changing. Here you can see both are 0. Here you can see both are 1 because this is the value of K and it is changing. And this value depends on these two things, C1 or R2. You can either write C1 or you can write R2 because this depends on these two. So it will be less than C1. And it will iterate for both the A and B array. You can see, so it will keep changing and it will gathering the different values. And that is a mathematical issue actually. If you find this program very complicated, it is nothing but like mathematics stuff. It is nothing related to like the program. So mathematics is really tough. Even I forget the mathematics, but yeah, after doing these programs quite a lot of time, now it is clear to me, but you have to practice those things as well. If you have any doubts over any points, just let me know. So our answer will be based on R1 and C2 as I explained. So the final array will be, the dimension will be R1 and C2, and I'm going to print the array Cij. So I will print something like printf, the result is, or the matrix multiplication is, whatever you can write. So I hope it should run. Otherwise, debugging this program will be pretty much tough. Let me pray for the best. Okay, what it is wrong. Okay, I have to give a semicolon. Okay, pray for me. Let me run this program. Okay, what is happening? K is not defined. Let me do that quickly. It should run. Otherwise, I have to spend a lot of time to execute this program. So first, I will deal with 2 row and 2 columns of the first matrix. For the second matrix, it is 2 row and 3 columns. So the elements are of matrix 1 is 1, 2, 3, 4. Elements of the matrix 2 is 5, 6, 7, 8, 9, 10. And it should give something like 21. And after that, it is 24. It is saying. So let me check if it is satisfying the result or not. 1 into 6 plus 2 into 9. 1 into 6 is 6, 2 into 9 is 18, 18 plus 6 is 24. Yeah, it is satisfying. So finally, the mathematics is correct. And it's, if you can write this program, believe me, if you are able to understand this program, at least 50%, if you have understood, I will say like it is more than enough, more than enough. In my whole college life, I never could do this program, means without copying it from the piece of paper. I couldn't, I was not even able to understand this type of program. So I hope I cannot explain it once again. If you need the explanation, you can just go through, you can again put the control 10 minutes back or 15 minutes back, and you can go through again with this explanation. Okay, but first of all, I will request you to do the mathematics. Just simple solve one mathematics, and after that you will be able to understand. Okay, and the program is here. You can simply copy this one. This is the main part of the program. You can type this program with me by putting the screen on hold, and I hope everything will go fine. If you are not able to understand, just let me know in the comment section. I will paste that code here. I will paste that code in the comment section, and I hope it will be clear. So now I'm not that good in mathematics as well. So if you know the mathematics, then it will be easier for you. Now another complicated loop I will show, like here, it is something like the spiral way. If I want to print it in this pattern, you can see it will be printed like this. I want to print it in a spiral way. So in this part, what I need to do, first, obviously, I need to take input everything. And after that, I will put something like, here. Okay, let me write it in the notepad itself. Let me delete everything. So suppose 10, 20, 30, 35, then 40, 50, 60, 65, 70, 80, 90, 95. Let me make it more complicated, like 11, 22, 33, 44, and more than that, 55, 66, 77, 88. So what I'm going to do now, first, I will put 4 variables, first of all. So let me first insert all those things. I, J, K, those things will not be needed. So only one matrix will be needed. And probably this is the last complicated program we are going to have. And after that, one simple program, and we will finish our class. So enter the number of rows of the matrix, or enter the number of rows, simply because we are dealing with only one matrix now. Let me delete all this thing. Enter the number of column, and it will be C only. That's all, I guess, R and C. And now let me delete everything from here. Enter the elements of matrix. Someone will enter the elements. It will be R and C, simply scanf. That's all on the input part. Now I will take something like, let me delete all this. What I will do, I will introduce few variables like first row as 0, first column as 0, last row as r minus 1. Similarly, last column as c minus 1. That means I want to put some variable like first row here. No, sorry, first column here, last column here, first row here, and the last row here. So first row will be denoting 0. That means it is on the first row. Last row means it will hold r minus 1, that the last row. Similarly, the first column and the last column. So now what I will do, first I will print all the elements of the first row from first column to last column. Means I want to print everything from 10 to 35. So what I will do, I will first write a for loop for I equals to 0 to I equals to first column to I less than, I have to be very careful till the last column. Every time it will be I equals to I plus 1. And I'm going to print this very smooth program, I will say. If you can keep your patience, if you can be calm, it will be very easier for you. Let me write. So I will going to print everything from the first row, but the column will be changed as per the I. So from the first row, I will print everything from first column to last column. So it will print 10 to 35. After we are done with this, I can move the first row because I have already printed that. So first row will be shifting to here because we have already printed that. So first row will be shifted here. So now let me do that. First row will be fr equals to fr plus 1. That's all. The next step, what I will do, I'm going to print the last column, but it will be iterated from first row to the last row. That means I'm going to print something from here to here of the last column. So what I'm going to do, let me write. For again, I equals to this time first row to last row. And I'm going to do like I equals to I plus 1. Very calm way you have to do. Very cool, keeping your mind very cool, you have to write that percentage D. Anyhow, you have to take the stress. So here the rows will be changing as per I, but the last column will be fixed. So I have printed the last column. That is 65 to 88. So let me write it here. 65, 95, 44, and 88 will be printed. So I have already printed something. I have already printed something like this. Okay, I have already printed something like this. So now what I need to do, I have already printed these two lines, and last column, obviously, I have already printed. So I can move the last column to the second last column. So what I will do now, I will do something like last column equals to last column minus 1. So now if I again go to here, so now I need to print this row. Means the last row from last column to first column in the reverse way. So if I going to write that, so for I equals to from last column to first column in the reverse way, so I will decrease by one position, and everything I am going to print from the last row. You can see all the elements belong to the last row. So I'm going to print something printf percentage D, and from the A, last row will be there and the columns will be changed as per the I. That's all. Once it is done, I will move the last row to the one place up because I have already printed the last row here. That means I have already printed 77, 66, and 55. You can see. So now my turn is to print the first row from 11, 70, and 40. So these three terms my next target is, and that belongs to first column. So again, the last for loop I will write for I equals to from last row to greater than equals to first row and I equals to I minus 1. And I'm going to print percentage D. A of rows will be changing as per I, but it will belong, all of them will belong from the first column. So after that, what I will do, first column will be first column plus 1. Similarly, here as well, I forget to mention last row will be decreased by 1. So here, after printing the first column, I will move the first column one position right. So first column will be moved into here. Okay, because I have already printed 11, 70, and 40. Let me write that. Let me draw that. So that has been done. So let me write it here. 11, 70, and 40 has been printed. So now what is the task? We need to do these things again for this one, means this loop again, the first loop again for the first row. You can see here in my code, first row, we need to print it again from the first column to the last column. Again, the last column I need to print. I mean to say here again 50, 60 will be printed. Again 60, 90, 33, that means the last column will be printed, and it will go on. It will go on until while first column is less than equals to last column, and then simultaneously, sorry, and then now it will be or first row is less than equals to last row. If it is still under limit, first row is under less than equals to last column and first row is less than equals to last row, then I will keep printing this in this format. I will just keep printing all the elements in this format. Okay, and it should print me the spiral way. So let me write it. Okay, let me check where I'm making mistake. Okay, I have not given semicolon, and that is nominal mistake, but this should run. Let me check. So number of rows, suppose 4, number of columns, suppose 5. Let me copy this out. 10, 20, 30, 35. Okay, let me copy this out. 10. Sorry, I have given something wrong probably. It will be 5 rows and 4 columns. Let me run it again. So 5 rows and 4 columns. So it should be 10, 20, 30, 35, 40, 50, 60, 65, 70, 80, 90, 95. Then 11, 12, something 11, 12, 11, 22, 33, 44, 55, 66, 77, 88. So it should print something in a spiral way. You can see if I compare the output 10, 20, 30, then 35, 65, 95, perfect. Then 44, 88, 77, yeah, perfect. Then 66, okay, I couldn't give 66, 55, 11. Then 70, 40, 50, I have to give some spaces there. And yeah, it is printing everything very fine. You can see it is printing everything pretty fine. After that 50, 60, 90, 32, 22, 80. So it is printing everything fine. Okay, so I just need to give one thing. I need to give a space here so that it should print everything proper. So this space will print everything in a proper way. So just you have to be very calm and you have to keep in track how the first column and the last column are changing. Even the first row and last row. If first row is under limit, first row is lesser than equals to last row, even same for the first column is lesser than equals to last column, that means everything is in control. So until it is in under control, I can keep printing, I can keep them printing like this way. Okay, you can keep printing all those things. So that is the way to print the spiral matrix. So if I come to the last program, so like rotate anti-clockwise. So in that case, suppose something like 10, 20, 30, suppose you have your phone, you put your phone like this, and now you have rotated in the anti-clockwise, and your phone will become like this. Suppose it is your phone or your purse, something like that. I have marked, okay, sorry, I have marked that in a way so that you can understand the direction of the rotation. You can see it will rotate in the anti-clockwise. I mean to say it will rotate into this manner, into this direction. So the top row will become the first column. You can see. So here it is pretty much simple. I really do not remember this type of programs, the codes. So if I want to write the code, this is probably the last code, not probably, I guess it is the last code itself. So 10, 20, 30, you can see. So 30, suppose it is a B, the normal array was the A array, and I will store the reversed array, the rotated array into the B. So the first element of the B, that is 30, and the position is 0, 0, that is coming from A 0, 2. Again, 30 in the B array, it is in B 0, 0, and it is coming from the original array. 30 is coming from 0, 2 position. If I keep writing this, so B 0, 1, that is 60. 60 is coming from the position like from A array. 60 is coming from, you can see, 60 is coming from here. 60 is coming from here. That means A 1, 2. Perfect. So if I'm going to write the B02, B02 means 90. So you can see 90 is coming from, 90 is coming from B02, 90 is coming from this position. So I can write something A22. Similarly, 20 in the B array, 20 in the B array is coming from, 20 in the B array means it is 10, I guess. B10. I'm trying to mean this 20 in the modified array. That is B10. And that is coming from here. That is A01. And if I keep writing these elements, I will get a pattern. You can see the pattern as well. You can see, let me find out the pattern. Yeah, these things are common as this thing. Those two things are pretty much common. Not pretty much, exactly common, I will say. So if I want to visit all the places of B array, let me clear all the drawings. Let me delete this code. So enter the elements of the matrix. So let me take another matrix called B, where I will put the rotated matrix, B 50 and 50, say. And I will deal with, suppose, a square matrix. I do not need to make it complicated. So I will just write into the size. Let it be very, let it take it in a very simple way. So first understand the logic, then we can obviously make it complicated. So now I can write something, a similar code to store the B array. Okay, I can copy the code because the loop will be same. And here what I will do, every time I will be storing Bij from some position of I that I need to track. So what are the positions of I and J from first array? So that will be my task. You can say, you can see like all the positions I am visiting of the B array, and I'm collecting the values for the B array, and I'm gathering it, I'm collecting it from the A array. So I need to understand how it is being collected. I need to check the pattern. So you can see here the similarity between these two columns, this column with this one. So I can write B, whatever is there in J, that will be equals to the position here. I can write J here as per the condition. You can see the column section of the B array is equals to the row section of the A array. First, you need to write this out. You need to track how the values are changed, how the values are coming from A to B. First, you need to track that. And after that, I can find the similarity like this. I can simply put J into the first position of A. And now if I want to find the pattern of the rest of the columns, means of this and this, So I can simply, I'm saying it is 2 minus I. So if I write something here like 2 minus I think that is satisfying. You can see 2 minus 0, it is 2. 2 minus 0, it is 2. 2 minus 0, it is 2. And 2 minus 1, it is 1. So whatever written in this first position, if I write something 2 minus I, it is satisfying this position, this pattern. So I think we are done. So obviously 2, from where 2 will come, it is generally n minus 1. If the size is 3 of that matrix, then it is 3 minus 1. So here size is n, I will write n minus 1. So that's all, I guess. Now I need to print the rotated matrix, rotated into anti-clockwise. So in the similar way, if anyone asks for the clockwise rotation, you can use the simple thing, the same way. You have to first track the changes and you need to write. So rotated matrix is, I'm going to print the B array, B matrix, or it is array as well. You can call it array as well, because it is a double dimension array. But yeah, today's class, you can feel the stress. So the same stress I felt in my college days as well. I couldn't understand those programs in my college days, but now after practicing a lot, now I understand what is happening there. But I know it is pretty much difficult for you to understand, but still let us try. So 10, 20, 30, we have to understand, because copying them out is just a temporary solution. We have to find some permanent solution, and you can see it is rotated successfully. You can see the pattern, it is rotated. So this is the way you have to rotate a matrix. So 10, 20, 30, it has been rotated here. You can see the first row become the first column. So if you find any difficulties, anyhow, I have to be that fast. I have to deliver things in that way, because there are too much program we have solved today, and all of them are pretty much tough, I will say, believe me. So but still, if you have some problem, obviously contact me. If you have any doubts over any section of this code, or if your code is not running fine, just paste that code into the comment section. I will try to take a look of that. All right, so if I go to this section, I hope everything is done now. So yep, everything is done. So you can solve the coding. There is one option. We have one exercise called coding exercise intermediate. You can refer to that and you can solve the matrix chapter. So in matrix, we have to solve 2 chapters. First is basic one, coding exercise basic album. And next one is the coding exercise intermediate album. So you have to solve both of them. And if you face any problem, you can contact me as well. And just have some time. Do not rush that you have to solve all the programs. Have some time in your hand and just try to check out all the programs one by one. Okay. Do not do it all together, because it will be pretty much tough for you. So I want to show you another thing before closing this session. So you can go through this album called Binary World. If you go to the media, if you go to the album, our targeted album is these 2. First one is coding exercise intermediate. You can also go to coding exercise basic. So if I go to the coding exercise intermediate, you can get a chapter called matrix here as well. So it is double dimension array, chapter 6. So you can solve this out as well. Okay. You will get many challenges here. Just try to solve. Okay. If you are looking for the solution as well, let me know. But first you have to solve this out. Okay. So that's all. And I guess it is the toughest class I have done in your syllabus. So rest of the classes will be easier. But yeah, we have to understand that. We have to fight. We have to understand. Okay. Anyhow. So bye for the day. See you again with some easier class, with some easier topic next day. Bye.